Hey guys, it's Miss Dales Reyes. Today we're working with exponent rules. Dividing with exponents is the law that we are focusing on today. So we have c to the 8th over c to the 5th. The easiest way to understand this is to go ahead and start by expanding it. So there's 8 c's in the numerator and there's 5 c's in the denominator. So for every variable that's on the numerator and denominator, that cancels to 1. So here, here, and here, and here. These all cancel to 1. So when you look at what's left over, all you have is c to the 3rd. On the bottom you have nothing, which is 1. But as you know, we don't have to write that 1 there. So it's c to the 3rd. Number 2, let's expand it. We have x and x on the top, and then we have 9 x's in the denominator. And we're going to cancel an x in the numerator with an x in the denominator. And then let's look what we have left over. It's really important to make sure that you separate your numerator and denominator. So in the numerator, you don't have anything right there, so you're going to hold the spot with a 1. And then you recount what's left over on the x's. There are 7 x's left over in the denominator. So 1 over x to the 7th. Okay, so this example is a little bit different. If you notice, in the numerator we have a negative exponent, v to the negative 3rd. In the denominator, it's just v to the 7th. So we need to talk about what happens when you have a negative exponent. The rule is you're not allowed to have negative exponents. You need to have everything in positive exponents. So the way you switch it is you're going to take any variable with a negative exponent and you're going to switch sides on the fraction, and then it automatically turns into a positive exponent. So once it switched sides, it's not over here anymore. So on the top we have just 1 because there's nothing left. In the denominator we have, if you were to expand this out and count it, 10 v's, so v to the 10th. All right, so we have f squared over f to the negative 10. Again, we have a negative exponent, so the first thing you want to do is you want to take it and you want to switch the sides to turn it into a positive exponent, and then you're going to simplify further, so that's f expand and add, that's 12 over 1. You really don't need the over 1, so just f to the 12th power. Okay, so w to the negative 10 over w to the negative 2. Start out by switching and making them positive exponents. Switching sides, making it a positive exponent. So now we have w squared over w to the 10th power. And when I expand it, that's 2 w's here, and then there are 10 here in the denominator. This will cancel, and you have just 1 whole left in the numerator. And then we're going to count up all the w's again, so that gives me 8. So that's w to the 8th power. Okay, m to the 0, n to the 1st over m to the 0, n to the 8th. Remember how we said before that anything to the 0 power is equal to 1, so you can just cancel that out, this one as well. So now we have just n to the 1st power over n to the 8th. You can expand it. 1, 2, 3, 4, 5, 6, 7, 8. These ends will cancel. So you have 1 over, count the ends back up, that's 7, 1 over n to the 7th. All right, a squared b to the 5th over a b to the negative 10. First thing, these two variables are not stuck together, they're separated. So technically they're separated by a time sign, and if you want to put it there to make it easier to understand, you can. We want to take the b to the negative 10th, and we want to switch the sides because it was a negative exponent. So now it's going to go to the numerator, and it'll be b to the positive 10. Okay, so if we expand it, we would have 2 a's, 5 b's, 10 b's in the numerator, and in the denominator, all we have is just a single a. So this set of a's will cancel, and nothing else can cancel. So then we count up what we have, and so we end up with an a, and all of these b's, that's 15 of them total, so b to the 15th. Okay. R, again, if you want, you can separate it to help it look easier to understand. R to the negative first times s squared times t squared. Okay. You want to switch all the negative exponents to the opposite side. So that's switched. This one comes up here. Okay. So now I have R, and I have 4 s's. In the denominator, I have 2 s's and 2 t's, and then 3 more t's. Anything that I could cancel, I will. So these s's and these s's will cancel. And then I'm going to check what's in my numerator. There's 2 r's, so r squared. There's 2 s's, so s squared. And in the denominator, I have these 5 t's, so t to the 5th. And this would be my simplified answer written with just positive exponents. So the correct answer is A. Okay, last one, x to the negative 2 times y to the 5th times z to the negative 3 over y to the negative 5th times z to the 8th. First step, switch negative exponents. So x to the negative 2 goes to the denominator, z to the negative 3 goes to the denominator, y to the negative 5 goes up to the numerator. Now I'm going to simplify. So you could use your exponent rules. You know that if you have 5 y to the 5th and y to the 5th, that's y to the 10th when you combine them. In the denominator, you have x squared and then z to the 8th and z to the 3rd. That's going to give you z to the 11th. All right, y to the 10th over x squared z to the 11th. Thanks for watching, guys. Bye.